There is another kind of function declaration that looks slightly different. And instead of using the fn special form, it uses a special form that is fn bang. Now, the reason there is this extra special form is because there is a particular type of function that is desirable within Berlin programming. And that is a type of function that strictly only operates on the parameters that it was given. This type of function is called a strict function in Berlin. What it means in practice is normally, for a regular function, let's say here at the top level, we declare some variable called x and we set it to 1. If we then have a function that, say, takes some parameters or whatever, it doesn't really matter, but let's say it returns x. Now, the reason this function has access to x is because it closes over its surrounding scope. It has a closure. And this can be handy in many cases. In fact, in some cases, I think it's required. It would be very difficult not to have it. But it can be overused. The problem with this kind of thing is that this function now has a dependency on its surrounding scope. It relies on its surrounding scope to have a variable called x, which means that you couldn't simply cut this function out of the text file where it currently resides and paste it somewhere else and it would work the same. It's not guaranteed to work the same. So in a video by Brian Will, unfortunately I forget which video it was, but it's in one of his videos on his YouTube channel, he suggested that it would be cool if there was a programming language that had this feature where you can declare a function of a certain type, and that is the strict type that Berlin has, which is if you try to access some value, some variable, some symbol that it wasn't explicitly given, it will throw an exception. And that is what a strict function in Berlin does. So if you try to do this in a strict function, the transpiler will throw an error. It won't even transpile the Berlin code, so you won't even get to runtime. So what it says here is, I cannot access the symbol x, this right here, in a strict function. Pass x into the function declaration instead as an argument, or declare it using a let block within the function. Remember here when you read this, because x is the last parameter, it's not a parameter at all. It's a block that the function executes. It just happens to be a block that only contains a single line, and so therefore we didn't need to pass the curly braces around it. But of course, this would be the same thing, right? So how would we fix this? Well, we would have to pass in x as an explicit parameter. Like that. It took me a moment there. So basically what this says is you take a parameter x and then you return it. That's all this function is. So it's an identity function again, right? And we're passing in x. But here in these parentheses, x is bound to the value 1, which is what we declared it to be earlier. So having 3 x's in a row might be a little more confusing to read. So let's call this a, just to show whoever reads this line of code that these are logically independent from each other. And so there you go. Now, as I said, strict functions have the advantage that they don't depend on their surrounding scope. They have everything they need given to them explicitly. And so therefore what they have greater referential transparency. Referential transparency is when you can cut out a function invocation from wherever it happens in your code and replace that part with the return value that you know that function invocation with those specific parameters would return. If you can do that, your function has great referential transparency. And that means it has greater modularity as well, because what you can now do is you could take that same function, you could cut it out of that part of your code and paste it anywhere else in your code, and you know for a fact that it will always do exactly the same thing. And that's a beautiful thing. As a convention in Berlin, if you don't use these as anonymous functions and you assign them to a variable, so now they're named functions, you want to end the name in a bang. This will alert anyone who uses your code or who reads your code that he can rely on this function's modularity. And so, yeah, this is how you would declare the identity function and pass in this bang. And in fact, the core of Berlin has an identity function that utilizes a function strict mode. It was declared this very way.